Hi everyone, I'm Carlos, and today I'll give you a brief presentation on our work titled DDTNBI, the de novo target prediction using a social network-derived method. As a brief introduction, target identification has always been a key step in the drug discovery and development. Hence, the need of methods to identify these kind of interactions are needed now more than ever. Computational methods have been developed to predict the possible targets for a particular chemical compound, but have shown to be non-effective when translating these predictions to the wet lab. Therefore, we need new methods in order to tackle this problematic. It's because of this that we have decided to ask other areas of studies how have they solved the problem of recommending possible outcomes for a given problematic. Our motivation is to improve current methodologies using concepts derived from other areas of studies, for example, social studies. Here, we showcase a new hybrid method inspired in the intersection of a social network-derived algorithm used for the recommendation of a possible product a user could be interested in, and a classical target prediction method in the form of chemical similarity screening. First step of our method is constructing our query network in which the social network-derived algorithm will work. Here, as you can see, in step 1, we calculate the descriptors for all the drugs contained in the bioactivity dataset. Then, we calculate the structural similarity between all the drugs and ignore all of the comparisons that we don't find interesting. We then construct a bipartite graph between the comparison of the drugs. In step 4, we annotate the targets for each drug and create a bipartite graph from this information. Finally, obtaining a tripartite graph constructed from the drug-drug graph and the drug-target network. This way, we create a tripartite drug-drug target network, hence the name DDTNBI. After the construction of our query network, we use a method called network-based inference in order to predict or prioritize the target for a known compound. Here, as you can see, the highlighted drug corresponds to the drug we want to prioritize the targets or predict the targets. As you can see here, the network-based inference method relies on the idea of spreading a resource throughout the network. Here, doing 2 steps of distribution or spreading of the resource, we can achieve a prediction or prioritization for the possible targets a drug will have. In order to assess the performance of this method, we used leave one out cross-validation over the gold standard dataset proposed by Yamanishi, where we can see excellent performance overall, reaching and even exceeding SDT-NBI, the state-of-the-art network-based inference method developed in 2017. As you can see here, there's a dependency between the similarity cutoff beta that we will use as a measure of whether a structural comparison is important or not or interesting, and the different fingerprints we used. As seen with the ROC area under the curves and precision recall area under the curves, we are reaching and even exceeding the performance of state-of-the-art methods. In conclusions, here we showcase a novel method for the novel prediction of targets using network-based inference on a novel query network. Here we use chemical similarity as a descriptor between different molecules, reaching a state-of-the-art predictive performance. But we still need to further understand the implications of how we construct the network and how the combination of parameters is giving this predictive performance. Thanks for stopping by in my presentation. I hope you liked it.